Hello everybody, I am Mohammad Azhar Iqbal Nawalgun, Assistant Professor, Department of Physics, Government First Grade College, Mundarki. Today we are going to discuss the interference. In this session we will discuss the definition of interference and types of interference. Interference. Interference is a phenomenon in which two waves superpose to form a resultant wave of greater, lower or the same amplitude is called interference. Or the other way of defining the interference is that the phenomenon of redistribution of light energy due to superposition of light waves from two coherent sources is called interference. In this process of interference, light energy is neither created nor destroyed, it is redistributed. Here we come across the term coherent source. If we say that two waves are said to be coherent, if they emit same frequency or wavelength and are in phase or have a constant phase difference, that type of waves are called as the coherent sources. Light from the two slits forms a visible pattern on a screen. The pattern consists of a series of bright and dark parallel bands called fringes. Constructive interference occurs where a bright fringes occurs. Destructive interference results in a dark fringe. The result from the interaction or superposition of two waves form constructive and destructive interference. These fringes are also called as maxima and minima, or bright and dark fringes. There are two methods of obtaining an interference phenomenon. The first method is the interference due to division of wavefront, and the second method is the interference due to division of amplitude. First, we will discuss the interference due to division of wavefront. In this, what is meant by wavefront? Wavefront is defined as a continuous locus of all the neighboring points vibrating in the same phase, that is, having same phase at a given instant of time. Interference due to division of wavefront. The incident wavefront is divided into two parts by utilizing the phenomenon of reflection, refraction, or diffraction. These two parts of same wavefront travel some different optical paths and reunites to produce interference bands. To obtain this type of interference, we have to use a point source or a very narrow line source. The instruments used to obtain interference by division of wavefront are the Fresnel biprism, Fresnel mirrors, Lloyd mirror, fillet split lens, laser, etc. Interference due to division of amplitude. The amplitude of the incoming beam is divided into two parts, either by partial reflection or refraction. These divided parts reunite after traversing different paths and produce interference. In these devices, broad light sources are used. The effects resulting from the superposition of two beams are referred to as two-beam interference, and those resulting from superposition of more than two beams are referred to as multiple beam interference. The interference in thin films, Newton's ring, and Michelson's interferometer are examples of two-beam interference, and Fabry-Peret's interferometer and Lummer-Gerst's plate is an example of multiple beam interference. Fresnel biprism. Fresnel used a biprism to show the interference phenomenon. The biprism consists of two prisms of very small refracting angles joined base to base. In practice, a thin glass plate is taken and one of its face is ground and polished till a prism is formed with an angle of about 179 degree and two side angles of the order of 30 minutes or 0.5 degree. Here we have taken a thin glass plate which is cut in the shape of prism, which have an angle of 179 degree and two side angles of 30 minutes or 0.5 degree. When a ray of light is incident on the prism, the ray bends with an angle. That angle is called as angle of deviation. The ray which emerges out from the prism appears to come from the source S dash, which is located at a upper position, a little upper position from the real source S. When we use the two prisms, we get the two virtual sources. The biprism creates two virtual sources S1 and S2 as shown in figure 1c. These two virtual sources are images of the same source S, produced by refraction and are hence coherent. In this section, we have discussed the definition of interference, types of interference, method of obtaining interference, interference due to division of wavefront, interference due to division of amplitude, Fresnel biprism. Now we will discuss some multiple choice questions. Question number 1. The superposition of two waves to produce bright and dark fringes is called option A, refraction, option B, diffraction, option C, polarization, option D, interference. The correct answer is option D, interference. Question number 2. Number of methods to obtain interference phenomenon. Option A 1, option B 2, option C 3, option D 4. The correct answer is option B 2. Question number 3. Interference is obtained by option A, division of wavefront, option B, division of amplitude, option C, both A and B, option D, none of these. The correct answer is option C, both A and B. Question number 4. Fresnel biprism consists of option A 1 prism, option B 2 prism, option C 3 prism, option D 4 prism. The correct answer is option B 2 prism. Question number 5. One of the angle in the biprism is option A 179 degree, option B 279 degree, option C 0 degree, option D 1 degree. The correct answer is option A 179 degree. The books which we have referred for this session are Textbook of Optics by Brijlal and Subramaniam, Refresher Course in Physics by Aurora, Optics by D.S. Mathur. Thank you.